Good, good day, student. How are you doing? Welcome to class. Today, we'll be dealing with the idea of momentum under force and motion. But at first, let's deal with impulse. A force will change an object's motion, make the object accelerate, and may make it change direction. The effect of a force F depends on how big the force is and the time t it takes to act. Impulse equation is written as Ft is equals to mv minus mu, where impulse is equals to Ft and mv minus mu is referred to as the change in the object's momentum. The quantity mv, which is mass times velocity, is known as the momentum of the object. Rearranging the equation above, in which Ft is equals to mv minus mu, F is equals to mv minus u divided by t. This is related to the equation F is equals to ma. This means that A is equals to v minus u over t. A is equals to v minus u over t depicts acceleration, F is force, m is the mass of the object. Now, let's deal with some single choice set of questions. A car of mass 600 kilograms is moving at 15 meters per second. We are to calculate its momentum. Don't forget that while dealing with impulse few seconds ago, I told you that momentum is mv. M stands for mass, V stands for velocity. So momentum is the product of mass and velocity. So going to the question once again, a car of mass 600 kilograms is moving at 15 meters per second. We have to calculate its momentum. With that, mass is equal to 600 kilograms. The velocity is equal to 15 meters per second. Therefore, momentum, capital M, is m times v, and that is 600 times 15. That gives let's check 15 times 6. That's 60 plus 30. That's 90. That will give us 90. That will give us 9,000 kilogram meter per second. Then, do we have it as part of our options? Yes, we do. Let's check it. That's correct. Also, a driver accelerates gently so that the force of 30 Newton acts on the car for 10 seconds. We have to calculate the impulse of the force. You know that impulse I is equal to what? F times T, where F is the force. F is 30 newtons times time is 10 seconds. That gives us 300 Newton seconds. Do we have it as part of the option? Let's check. Let's pick and look. Correct. Now, also, we have to calculate the moment of a car of mass 600 kilograms moving at 25 meters per second. That means we have m equals to m times v, and that gives us 600 times 25. 25 by 6, that's 120 plus 30. That's 150. So this becomes 1,500 kilogram meter per second. Do you have it as part of the option? Yes, we do. Let's check. Oh, we can retry that. Okay, let's go once again. Okay, students, let's go once again. We know that M is equals to M times V. That will be 600 times 25. Okay, which can be written as this. M is equals to M times V. And that is 600 times 25. That will give 15,000 kilogram meter per second. Is it part of the option? Yes, let's check. Correct. Now let's move on. Which of the following statements about mass and weight is correct? Only weight is a force. Only mass is a force. Mass and weight are both forces. Neither mass nor weight are both forces. Don't forget that mass is the quantity that is associated with an object or a body. A weight is the product of mass and acceleration due to gravity. So, and weight will always act downward. That shows that it is a force which has magnitude and direction that acts downwards. Therefore, only weight is a force. Let's see. So we proceed. Now, momentum in a collision. Whenever a force acts on an object, its momentum changes. At the same time, the momentum of the object causing the force also changes. If one object gains momentum, the other object loses an equal amount of momentum. This is known as the principle of the conservation of momentum. So let's drag these words and see. The principle of the conservation of momentum can also be stated that whenever, let's see, two objects interact, the total amount of momentum before they interact is the same as the total amount of momentum afterwards. That is, total momentum before collision is equal to the total momentum after collision. That's the principle of conservation of momentum. So let's check. Good. Correct. Now, let's go to the principle of conservation of momentum. The principle of conservation of momentum is illustrated in this diagram below. So, we have the momentum of the racket before collision, that is, before the racket hits the ball, and after the racket hits the ball. What will happen? That means that the ball will undergo, we have velocity, while the racket becomes stationary or has a drop in velocity. That is after collision. Now, with that in mind and with this illustration, let's solve the problem we have here now with this diagram. The illustration in the diagram below shows the masses and velocity of the racket and the ball. We have to find A, the momentum of the racket before and after the collision, B, the momentum of the ball after the collision, and C, the velocity of the ball. Now, let's do it one after the other on the screen. For A, momentum of the racket before collision is equal to, we have, what is it, mass 3.0 times 20 kilogram meter per second, and that gives 60.0 kilogram meter per second. So after collision now, we now have it as 3.0, the same mass, times, that is 18 meter per second. That's the velocity, and that gives 54 kilogram meter per second. So for B part, which is the momentum of the ball after collision, that will now be 60 that we have before and after, which is 54. 60 minus 54 kilogram meter per second, and that gives 6.0 kilogram meter per second. For the C part, we have momentum is equal to mass times velocity. Now that we have the momentum to be 6 kilogram meter per second, and the mass after the collision, is 0.25 kilogram. Mass after collision is 0.25 kilogram. We are to look for the velocity associated with the ball. So V now is capital M over small m, and that gives 6 over 0.25. V becomes 24.0 meter per second. Don't forget, for A, we have 60 kilogram meter per second. That is racket before collision. After collision, we have 54 kilogram meter per second. So the momentum of the ball after collision is 6 kilogram meter per second, while the velocity of the ball is 24 meters per second. So let's see whether we have the options there. All right, 54 kilogram meter per second, 6 kilogram meter per second, and 24 meter per second. Okay, let's check. That is correct. Now let's proceed. So with that, we'll have to do the summary for today's class. We have to choose the correct statement. When a force acts on an object, its momentum changes. Is that correct? Yes. Why? Because force causes an object to act. And it changes the mass, it changes the velocity and speed of an object. When a mass acts on an object, its impulse changes. That statement is false. Mass does not have any relationship with impulse. When a weight acts on an object, its momentum changes. No, the statement is false. So when a force acts on an object, its momentum changes. Let's see. That's correct. We've come to the end of today's class. Do well to visit our website www.edubbey.com for more of our interactive books. Thanks so much for watching us. See you next class.